everything we're talking about. All brand new stuff for you. Another reason I love it. And our ultimate goal of this chapter is to be able to find all the zeros of a function without me telling you anything. Up until this point, we've either maybe given you a zero, or we said, hey, this is a factor. You've kind of had a starting point. Or maybe the problem factored out nicely for you, and you could solve them that way. Eventually, that's not going to be the case. I can't factor on it. It's just a hot mess. I need some other skills to try to solve it. So that's what we're going to talk about here today, is some other skills, working our way up to being able to find out the zeros. So we're going to do what's called the rational zeros. Rational is fancy name for fraction. Descartes' rule of signs. That kind of helps you narrow down like how many positive answers you might have versus how many negative. And then we're going to talk about, algebra and using our calculators, etc. So first thing we're going to get into or start talking about are these rational zeros. So most of the time we have seen that we can factor things out. That is not always the case. So we need these other skills. So this is just for fun. If you multiply the answers together, -2 times -3 times 4, what do you get when you multiply those together? Yeah, just notice what your constant term is there. Sometimes that's kind of a neat little thing. Now, if I can't factor the polynomial, I look at it and I'm like, gosh, there's no greatest common factor. I can't factor it by grouping. Nothing multiplies to whatever and adds to the middle. Then I'm going to go to this strategy. This gives you all the possible rational zeros of the function. Notice I said possible. Not actually all the answers, possible. Now, that polynomial looks crazy. One of the things we're going to P over Q. Now, how do we find those? The P and the Q. Factors of the constant term. Now remember, the constant term is, go back to this guy, would be 24. Our constant term is always the term that does not have a variable. So I would be thinking about all the numbers that go into 24. 1, 2, 3, 4, 6, 8, we got it. Okay, 12, I can keep going. Nobody wants me to keep going. And then, of course, factors of the lead coefficient. Lead coefficient is your first number. This will give you a starting point, a list of possible answers. So that is the first thing we're going to practice. So use the rational zero test to list all possible rational zeros. And then we're going to talk about verify. So first thing I'm going to do is just look at my constant term. And notice I started you with some very small numbers, okay? 2 is prime. The only numbers that go into 2, of course, 1 and 2. So that's easy. Then I'm going to look at the lead coefficient. Again, I started you with small numbers on purpose. So I'm going to list all the numbers that go into 4. 1, 2, and 4. Now, how to make your list of possible answers. Possible. 1, all of them have plus or minus in front of them. Positive and negative. I don't like to write plus or minus all the time, so I just throw it out in front and put them in parentheses. And define them. You're going to do all the factors of the constant term. So the red numbers over each of the green numbers. It's the factors of the constant term over the factors of lead coefficient. So I'm going to do 1 and 2 over 1. 1 over 1, 2 over 1. Okay. Then I'm going to do the red numbers over 2. 1 over 2, oh good, fraction, 2 over 2. Well, that's 1, I already have it listed, I'm not going to put it again. Then I'm going to do the red numbers over 4. 1 over 4, oh good, good fraction, and 2 over 4. Well, I already have a half on here, so I'm not going to put it again. Now here's where it gets fun. Look at the original polynomial. How many actual zeros are there to it or solutions to it? 5, right? 5th degree. How many potential answers do I have here? 8. Okay. So here's where it gets super fun. You're really going to love it. We're going to pick numbers off our list. We're going to pray that we're good pickers. We have good luck. We're going to do synthetic division and see if the remainder is 0. If it's not, I pick a different number and I know the looks on your faces are great. I synthetically divide till I get a remainder 0. That's what's coming at us. Okay, we'll wait till we get there. So same thing, we're just practicing finding our possible answers. So first I start with the constant term. I'm like, all right, everything that goes into 2. Got it. Then I think of my lead coefficient. I love the lead coefficient. 1, everything goes into 1. Okay, so to get all my possible zeros, They all have plus or minus. It's the green numbers over 1, the green numbers over 1. That's it. 1 over 1, 2 over 1. So third degree, 3 answers. We have 4 possible listed. This is when I said let's pray that we are good guessers today. So here we go. This is what we're going to be doing. So of course I'm going to list all my possible zeros like we just did. I'm going to use synthetic division and hopefully pick wisely until I get a 0 remainder. If I don't get a 0 remainder, I keep dividing. And then we will get it down to a quadratic that we can solve hopefully by factoring quadratic formula, completing the square, whatever. The key is we want to be good guessers here, not have to do synthetic division a million times. Okay, let's do it. Are you ready? Now, I'm looking at our polynomial. How many total answers should there be? 3. And previously, I would be like, oh, there's 4 terms. I'm going to factor it by grouping. Well, factoring by grouping is a fail, okay? It doesn't factor by grouping. So I'm like, here I go. I'm going to list all my possible answers. I'm going to write small in case we guess poorly and see what we get for a 0 remainder. I'm going to start with 6, of course. All my factors are 6. Then I'm going to list all the factors of the lead coefficient, 2. And then, of course, my possible answers, they all have plus or minus. It's all the red numbers over 1. Well, if I do all the red numbers over 1, it's just themselves. And then all the red numbers over 2. So 1 over 2. Oh, gosh. This list is getting longer. I don't like it. 2 over 2. I already have 1. 3 over 2. And 6 over 2. 3. I already have. Okay. Let's close it off there. So 3 answers. I have how many potential listed here? 12. Yep. Okay. All right. Who wants to pick a number off the list?
Owen does.
Owen? Hit me.
Number 3.
What do you want to go with?
Number 3.
You want to use 3?
Yeah.
Okay.
If you're wrong, I'm
So I'm going to do 3. I'm going to do synthetic division. I'm already nervous. We need a 0 remainder. Line up your coefficients. 2x cubed, 1x squared, negative 13, and 6. Now I have the power of the smart board, so if I run out of room, I can always erase. Okay. All right, 3 times 2. I'm going to add these. 3 times 7. What's negative 13 plus 21? Oh, man. Is it going to work?
No.
No, because we're going to have 24. Our remainder is 30.
Thank you, Owen.
Thanks,
So, no dice on 3. Who wants to pick? Caleb?
Negative 3 halves.
All right, line them up, same coefficients. Are we having fun yet?
No.
I know, I'm just laughing. What's negative 3 halves times 2?
Negative 3.
Add those.
I'm so sorry.
Negative 3 halves times negative 2. What's a negative 3 halves times negative 10? How's that looking? Can I guess one?
Yes.
Yeah.
You can guess 3 if you want.
How about, I'm going to guess 2. Can I erase this? Because I'm running out of room. Okay. So, yeah, I'm going to guess 2. That's a 2. I don't know. That's my bad leftover erasing. All right. 2 times 2.
Oh my gosh, that's bad.
2 times 5. 2 times negative 3. Man, I'm a good guesser.
Kelly, you pick.
That was my next guess.
That was your next.
That's
To be
mine.
fair, if you, I don't know how well you can see here. When you can see, I tried a couple and I have them like X'd off. Okay, So it's not just I magically was like, oh, 2. Okay. All right, recover this. 2x squared. Okay, so we have one answer. I'm going to give 2 a big circle there. The other 2 answers are going to come out of this quadratic. Now we know lots of ways to solve quadratics. Factor, complete the square quadratic formula. I'm going to take a look at this. I'm going to set it to 0. I feel like this one would factor for me. Those are small numbers. I'm just going to try to unfoil it in my head. So to get 2x squared, of course, 2x and an x. The only way to get 3 times 1, so I'm just kind of in my head trying to unfoil and figure out where I'm putting the 3 in the signs. I'm going to put the 3 here and a 1 here. And what are the signs? Plus, minus, 1 of each. What do you got going?
Plus 3 minus 1.
So, plus 3 minus 1. Take a look. I like it. What are your last 2 answers?
Oh, that's actually so small.
Positive 1/2.
Positive 1/2. Add 1, divide by 2. And negative 3.
Why didn't we just do that? Yeah.
So, do we have all 3 answers listed?
Yes.
Yes. Was that painful and it's making us hate math?
Yes.
Potentially. Now, you know, I always like to make you suffer a little bit, let's just be honest, and then I might have some
Why are we getting
little
the
tips
2?
for you. Where what?
Why are we getting the 2?
Where did I get the 2?
Literally-
Oh, why?
No,
Why?
like, where's
Because you got 0 as a remainder.
Yeah, like
no, but like, where's that going?
Yeah.
So that's just one of my answers, one of my 3 answers. When you get a 0 remainder, means that is a solution to your polynomial. It divides evenly in there, it's a solution. So 2 was my first
Oh, so that's
answer
our answer.
that I pulled off the list. 2 worked out for me, so I kept it. And then I just solved my remaining polynomial off it. Don't worry, we're going to do more. Ready?
Wait, so technically couldn't you just keep doing synthetic division?
You could have picked other numbers and kept picking and choosing, but once I got this thing, I was like, oh dude, I can factor that, and I can make my life easy, because clearly the guess and check was stressful. Okay, let's try this one. Are we ready? Oh god, I crossed off a couple here. So, blah, 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 find all the zeros, sketch it. We'll do the sketching at the end. Now, first question. How many total answers should there be? I'm looking at that polynomial. I'm like, there's 5 terms. I can't group 5 terms. There's no greatest common factor. I cannot factor it. So, back to the list and praying. Okay, so 10. What are all the factors of 10? 1, 2, okay. That's not awful. That's not too bad. Lead coefficient, super happy 1. Only factor 1, okay. Feeling good, feeling good. So my possible zeros, they all have plus or minus. It's all the green numbers over 1, which of course are just all the green numbers. Okay. So technically, oh boy, technically how many possible answers are there listed here? And we only have 4 answers. So let's hopefully guess wisely. It sounds like Kale has a guess.
What is it, Kale?
He's scared to say. I thought that somebody over here whispered
I
a
thought
good
you said
one.
you have it, and then you were like
Well,
asking
I did
everyone else
have
for the
it.
answer.
I guessed 1.
Well, the answer to the last one was 2, so.
What are those there?
And that,
Okay, 3 amigos are holding up 5, so let's try 5.
Kale, you're useless.
Okay. Brutal. Okay, line up your coefficients. We're in the correct order. And we're looking for what remainder? 0. 5 times 1. 5. Add. I feel like I'm missing something. I was like, wait a minute, I'm missing a negative 5. I'm like, hold on. I just said to line them up in order, then I didn't need to do it. There we go. Okay. 5 times 0. Add. Negative 5 times 5. 5 times negative 2. How's it looking?
Alex, you cheated. Alex, you cheated. You looked at the answer key.
There's an answer key for the notes?
Yeah.
Where?
Interesting questions. Okay, so one of our answers is what? 5. So we got a 0 remainder. We have how many more answers to go?
3.
So, so let's recover this and take a look at it. I have 1x cubed. I'm not writing 0x squared. Minus 5x minus 2. I'm looking at this, I'm like, man, can you factor on that? We sure cannot. So, I'm going to scroll down because I'm probably going to have to hit extend page. Well, you know, let's just hit it and just, yeah, okay. So, so look at your list. Look at the list. Look at the list. Now, here's the thing. If I can finally get this down to a quadratic, a squared, I mean, worst case, I could use quadratic formula on it. The key is I really need to get this down to a square. Now, whatever is the 0, and I'm clear at the top, obviously, of the original polynomial, that list of possibles, is also zeros to this guy. It's kind of the ripple effect. So I don't want to keep going on the original because it's just obnoxious. I'm going to work on lowering this down. So I'm going to use these coefficients now. I'm going to use 0, 0, no squared, I almost missed it. And who wants to pick a number off the list? Can I pick a number off the list?
Yes,
Negative
please.
to one of them?
I'm going to go with Riley's. He said -2. Let's give it a whirl.
This isn't right.
-2 times 1, add. -2 times -2, add. Riley, I think we got a good pick here. -2 times -1. So -2 is my second answer. Now, recover this for me. Hang on, Elliot. What is this? 1x. 1x, we're down to power, squared, minus 2x, minus 1. So my last two answers will come out of this quadratic. Now, once I get, you're going to hate me. You're really going to hate me on this. Does that quadratic factor? No. No? So we're either going to do it again, square, or use quadratic formula. If I could tap dance right now, I would. This has like every skill you could ever possibly. God, I love it. Okay. I mean, I'm going to go completing the square because I can do half a 2 in my head pretty quick and square it and do all of that. So I'm going to add the 1 over, get it out of the way. So let's just have plus 1. We're going to recalculate this third term to force my trinomial to factor. So half a 2 is 1, 1 squared. Now putting that red 1 on, so many ones here, the red 1 forces the left side to factor. Multiply to 1, add to -2, -1, -1. And I'm going to combine the ones on the right. I'm going to cancel squaring with the square root. I'm going to remember my plus or minus. Luckily, 2 is prime, so I don't have to simplify, but we always think about simplifying our radicals. We're going to remember that on our quiz tomorrow. And my last thing I'm going to do is add the 1. Okay, so take a look. Do I have 4 answers? Yes, because plus or minus 2. 1 plus square root of 2, 1 minus square root of 2. We still have to draw the graph. I don't have tall enough shoes on. I'm gonna have to scroll it up a little bit. Okay, so to do the graph, and this is, I love this. This is kind of why I threw the graph on too. This is good review for your quiz tomorrow. So to do the graph, I'm going to plot these zeros on the x-axis. I'm going to have to grab my calculator and figure out the decimals equivalents to this and just kind of estimate them best I can. I'm not going to get too stressed about it. But let's review end behavior, falling, rising, and of course whether they touch the x-axis versus cross. So to get into all of that, let me scroll it back up to the original polynomial so we can see it there. So 4th degree, that's what I'm looking at. So the 4th degree, of course, the ends work together. They're either both rise or both fall. Positive 1, lead coefficient, they're both going to rise. So have that in your head. I've got all the zeros. I've got 5, let's mark it. I've got -2. And like I said, I punched them in earlier just to cheat. I punched 1 plus the square root of 2. Well, actually, I didn't. Because square root of 2 is about 1.4. So 1 plus 1.4, 2.4. And then 1 minus 1.4 gives you negative 0.4. So I just kind of did the decimal approximation of those so I knew where to plot them on the graph. I'm not going to get crazy. We know I can't draw. I'm going to estimate it. 2.4, negative 0.4. Now, it's not going to be a factor here, but let's just review. How do you know whether your x-intercept, your solution, crosses the x-axis versus sits on it and touches it? We need to know it for our quiz tomorrow. Elliot?
It has to do with if you have duplicates of the same answer, how many duplicates you have.
Perfect. An even amount of duplicates, you touch, add, cross. Now we have all singles. A single 5, a single negative 2, a single of these decimals. So left end rises. I'm going to hit my first 0. I'm going to cross, cross, cross. Wasn't that fun? All right, any questions on that? Let me give you a sec to be right. Now, the next thing I have, the next little and last little tool I have for you, and this I think is a little helpful. It's not super helpful. It's called Descartes' rule of signs, okay? You're counting sign changes. It's very simple. But what's nice about it, it might kind of help eliminate some of our guessing. Meaning, it might tell you how many positive answers versus negative. Like if there's no negative answers, clearly I'm not going to guess any negative numbers off my list. So it's going to help kind of whittle down our possible answers, hopefully, and make our guessing a little better. Hopefully, keyword there, hopefully. Okay, Descartes' rule of signs. So, in some cases, the following rule, discovered by the French philosopher and mathematician, hopefully you've heard of René Descartes, is helpful to eliminate candidates from lengthy lists of possible rational roots. Okay, so to do this, we are going to count the variation in sign. So, and you can see here, positive, that's what I'm talking about, positive to negative, there's 1. Negative to negative, nope. Negative to positive, yep. Nope, yes. So there's 3 variations in sign. So we're counting the sign variations. That is what we are after, my friends. So you're going to count the variation in signs. That is going to tell you how many positive real answers, real of course, we're not doing imaginary right now. And then there's this weird little note at the end, or less than that by an even whole number. Okay, what does that mean? Less than that by an even whole number. So that means basically even whole number. You're subtracting 2. So, let's say I give you the world's longest, craziest, most ridiculous polynomial, and you count 5 sign changes, okay? So that means there could be 5 positive answers, 3 positive answers, I subtracted 2, I can subtract 2 again, or 1 positive answer. Basically, you have a guarantee of a positive answer, so I'm picking the positive numbers off the list. I'm not going to try negative. Now, if you want to know how many negative potential answers there are, it's kind of the same thing, but you have to first replace the x's with a negative x, simplify of course, and then count your sign changes, and of course subtract 2. So it's kind of helpful because it kind of helps whittle down your list, so to speak, so you kind of maybe can make some better guesses. Descartes' rule of signs. Let's try it. Okay, use Descartes' rule of signs to determine the possible number of positive and negatives. Okay. Hey, we don't have to find them. We just got to figure out how many. So, first up, count the sign changes. So just go through the terms. Tell me how many times does it change sign?
1 time.
1 time. I like that. Because that, I know for sure there is a positive answer. I would pick positive numbers off my list for my synthetic division. So of course you had your 1 sign change. So for my positives, I'm just going to put 1. Now, it also asks you to do negatives. So before I do my negatives, you have to replace all the x's with a negative x. Of course, I'm going to simplify this down, and then I'll recount my sign changes. And as always, I swear I say it 10 times a day, we got to be super conscientious of our signs. Okay. So there's the setup. Let's simplify it. So think about this. An even I'm not going to get crazy here. I'm just going to remember an even amount of negatives is a positive. Odd amount of negatives results in a negative. So if I have 6 negatives, the overall sign is going to be what? Positive. So I just have 3x to the 6th. 5 negatives makes a negative. So I'm going to have plus negative, I'm not going to write plus negative 4x to the 5th. Plus negative, I just went minus. 3 negatives makes a negative. Minus a negative. Minus 3 is minus 3. So now that I've done all of that, go through, count your sign changes. What do you got? 3. Here's 1, 2, 3. So that means there's 3 or, because you have to subtract 2 down if you can. Clearly here, I'm not going to subtract 2 off. It goes into a negative, which is just weird. Negative answers. Now, here's the thing. You're really going to love me even more so than normal on Monday. But I'm looking at this, I'm like, this really isn't very helpful. If I'm trying to get my zeros and I have my possible list, I know for sure there's 1 positive and there's 3 or 1 negative. So I know there's at least 1 positive, 1 negative. Does that help you whittle down anything on your list? No. No, it sure doesn't. Okay, so let's try it. Let's try it. Okay, are we ready for this? Here we go. It's going to be good. I'm excited. You're excited. So it says factor the polynomial. Funzo. Okay, so I'm looking at that. Can you factor that right now? So what I'm going to do is I'm going to find all the zeros. And let's say once I get my list of zeros, 5, 7, 2, 3, whatever they are, then I can just pop them back in factor form, x minus 5, x minus 2, whatever. But to find all the zeros, we got to make the possible list. We got to be good guessers. We might have to cry a little bit. I don't know. We'll just see what happens. So let's start with our possibilities. 9. What are all the factors of 9? I'm glad there's not very many, right? Lead coefficient, 2. Factors of 2. Got it. So my possible zeros, it's going to be all the red numbers over 1. It's just all the red numbers. And all the red numbers over 2. Oh, good, a lot of fractions. I'm real excited about that. 1 over 2, 3 over 2, 9 over 2. So we need 5 answers, and I have 12 possibilities. I don't know about you, but I don't feel very good about that. All right. Now, I'm going to see if I can maybe whittle down my list here a little bit and see maybe for sure there's like a guarantee of a positive answer or a negative answer. So I'm going to quickly go through and count my sign changes here to see if that might help me select a better guess. No sign change. Here's a sign change. Sign change. I don't know if that really helped me. Because how many sign changes are there total? So that means there is either 2 positive answers or is none. I feel like that's a gamble, right? 2 or none? Oh, God. So we could replace the x's with a negative x, simplify and recount, or it's kind of a gamble. If there's 2 or 0 positives, what do you think the likelihood is there's a negative answer? Pretty good, right? So, I mean, we got a lot of work to get these 5 answers. So I'm not going to waste any time throwing in a negative x and recounting. Just seeing that 2 or 0, I think it's a good guess to pick a negative off the list. Who wants to pick a negative number to try? Elliot.
-3.
I like that.
Oh, do you?
So, let's do our synthetic division. Make sure your terms are in order, and our remainder, of course, should be 0. I feel like I'm going to have to hit extend page, probably, but hey, whatever. All right, -3 times 2. What's that? -3 times -1. Negative 3 times negative 5. Negative 3 times what? Negative 3 times 3. Oh, good guess. I got it. So there is one answer. Circle up negative 3. Now, how many more answers do we have to go? 4. So, let me scroll. I need to make some more room here for this. Okay, so my choices are this. I can pick, I'd probably pick another negative, of course, and resynthetically divide till I get to 0 remainder. But I'm going to try to whittle this down till I get it to a square. Because if I can get it to quadratic, man, I can, quadratic formula or do something, whatever I have to do. So I'm recovering this. I'm thinking to myself, of course, this is 2x to the 4th minus 1. I don't know why I put the 1. We know what's there. Habit, I guess. So I'm going to work on solving this polynomial. Now, any potential zeros on my list, my blue numbers, are also zeros to this one. So I'm going to divide this one down. I'm going to keep dividing until I get it to a square. So, obviously we already picked negative 3. What would be another good negative number to try? Let's try it. All right, so I'm going to work on this green one. Now it's up to you really, like how I rewrote out the whole polynomial, or you're just using your coefficients. Okay, so 2, negative 1 times 2. I'm going to add negative 1 times negative 3, 3, add negative 1 times negative 2, 2, add negative 1 times 3. Second answer. Win it. Okay. Now again, if I were to recover this, not that we have to write out the whole thing, but we would be down to 2x what? Cubed. Minus 3x squared minus 2x plus 3. Okay. How many more? I know I'm giggling. How many more answers do we have to go?
3 to go.
I know. How do you feel about that?
Pretty horrible.
Pretty horrible too. Okay. Now, here's the thing though. I'm looking at this because again, I picked different numbers. I divided differently. It doesn't matter. We all get the same final answers. But while I'm kind of standing here looking at this, I'm like, oh God, I really don't want to divide. I'm running out of room. This is causing me anxiety. You have 4 terms here. I was just doing a quick mental check. Can I factor that by grouping? Is that going to group out? Yes. Praise the Lord. Okay, so let me write this over here so we can see what I'm doing. I'm going to set it to 0. Now, if that didn't group, I would be picking another number off the list and synthetically dividing till I got to square. But I think we got lucky, and we can group it. I'm going to pull x squared out of the front. I'm going to take a negative out of the back half, a negative 1, so I can switch the sign so my parentheses match. So my factors, 1 of course is my matching set of parentheses, and then the GCFs. And I think we can, with no more work, get all of our answers here. What else? What do you got? This is going to give you 3 over 2. Can you get the 2 answers out of this in your head with no more work? Plus or minus 1. So take a quick gander. Do I have all 5 answers up here? Who wants to cry? Now, wait, we're not done. I love it. Let's read the directions. What's the first word in the directions? So I have all the zeros. I have all the solutions written down. Yeah, I'm going to slap it up front there. I'm going to write out for my final answer all of them in factor form. So negative 3 I'm going to write as x plus 3. Then we had negative 1. I'm going to write that factor style x plus 1. Remember, 5th degree, I should have 5 factors. 3 halves, you can see the factor right above it out of the fraction form. I'm going to put 2x minus 3. And then I'm going to use plus or minus 1. X plus 1, x minus 1. Do you have all 5 factors now? I know there's some repeated ones, but we do have technically all 5. Are you ready for this, Phil? Elliot, I'm ready, sorry.
Is it 2x plus 3 or 2x minus 3?
2x minus 3, because our answer is positive 3 halves, so I want to add 3 divided by 2. So, okay, so look at, sorry, go ahead, Elliot.
Oh wait, no, never mind. I see
Okay.
just my issue.
Are you ready for this? Are you ready for it? Ready?
No.
So there's 5 answers, right? Now, out of those 5 answers listed up there, would you say they're nice or they're not? Pretty nice, right? So if I were to, I'm going to say this with a straight face, if I were to graph that on my graphing calculator, where would it hit the x-axis? I could have done that with no work and just looked at the graph. The looks on your face, I love it! Which is what we're going to start doing some more of on Monday. But like I said, I know the looks is priceless. I like to make you suffer a little bit and understand the math behind all of this. Isn't this great?
No.
I love it. I really do. Okay, so this is what we're going to start leading our way to. We're going to take a look at the graph on the old calculator. I know. We're going to use our 0 feature. Remember, that's in second trace, the 0 feature, to determine one exact answer. There could be more. I just need at least one answer. We can then do our synthetic division. I don't have to guess numbers anymore. And then from there, you could hopefully maybe factor. So I'm going to say use factoring, quadratic formula, completing the square, any of those choices. So I'm going to put quadratic formula. So, I can't stop laughing because it looks on your faces. If I just on that last problem said solve this, the first thing I would have done is grab my calculator and look to see where it hit the x-axis. I would have wrote them down and been done. Love you guys. Okay, so let's look at this one. Find all real solutions. Round to the 10th. It says round to the 10th, so I'm guessing we're going to our calculators, right? Let's graph it and pray. All right. I have a whole lot of stuff in here. 3x to the 4th. X cubed. 7x squared. Minus 2x. Don't judge my slow typing. I'm just making sure I didn't have a typo on this thing because okay, hit graph. I don't know what my window is. I'm actually the one I don't know. Okay, so how many total answers should there be to this polynomial? 4. Okay, 4, it's a 4th degree. How many places does it hit the x-axis? So that means there's 2 real answers, which I'm going to have my calculator get, and the other 2 would be imaginary. Doesn't ask me for the imaginaries today. Next week, we'll be getting the imaginaries. So God, I love it. So I'm going to do my second trace. My number 2. I'm going to left arrow over till it's close to the point. We've done it. Come on, cursor. He's off the screen. He's coming back. There he is. Oh, what? Too far. Too far. Yeah, he's got a big jump there. Enter. Scroll below the x-axis. Hit enter. Nobody wants to guess. It's stupid. Round to the 10th. I'm going to go negative 2.3 on that one. And then you're going to do the same process and find the right one. I'm just going to save you. The right one's about 1.3. So, if I were just doing these problems and I wasn't trying to do them without my calculator, I probably could have done this whole lesson in about 10 minutes. Love you. Which is what we're going to do next week.